The final example in this extensive lesson 5.5 is another sum to product. So what we want to do is we want to rewrite this one as a product of two different trig functions. So I'm going to think of this as alpha and 5x is beta. So then I'm going to go grab the correct sum to product identity. So we got the cosine of alpha minus cosine of beta, so I have to have equals -2 times the sine of alpha minus beta, which is 3x minus 5x all over 2, times the sine of, I guess I just put it in a different order. Let me come back. It's -2, and if I interpret the look here, it's alpha plus beta, so it's 3x plus 5x all over 2. Not that it would make any difference because it is commutative, but that way you know exactly where I'm coming from, that it's alpha minus beta, which is 3x minus 5x all over 2. That's got to equal 0. Just put it over here. Okay, so we'll come back through and we'll say this is equal to -2 times the sine of, this is 8x, and 8x divided by 2 would be 4x, times the sine of, and this is going to be a -2x, divided by 2 would be a -1x, and that's supposed to equal 0. Then we'll come back through again, only this time I'll multiply or divide both sides by -2. So if I divide both sides by -2, we still get 0 equals, you got the sine of 4x times the sine of a -x. Make sure I get that negative in there. Right, and then we'll apply our zero factor theorem again. So the zero factor theorem states if each of these, if our product is 0, then one of those factors has to be 0. So sine of 4x equals 0. Or our other possibility is the sine of a -x has to equal 0. So in this case, we'd have to come back and say we're looking for the angle whose sine value is 0. So 4 times that angle has to equal 0. Keep finishing that branch. So that means 4x has to equal, sines are only equal to 0 at 0 and at pi, plus their wraparound angles, so plus 2 pi n. And then what we'll do is we get rid of multiplying by 4. And to get rid of multiplying by 4, I'll multiply both of these times 1/4. So that's going to be 0 plus, we take the fourth of 2, that should be pi halves n. And the other one should be pi fourths plus pi halves n. So we could just shorten this one down to pi halves n, and then we got pi fourths plus pi halves n. Okay, and then on the other strand, or the other branch, what we have is the sine of a negative theta. Well, the sine of a negative theta is equal to the opposite of the sine of theta. If you use your even and odd identity, then divide by -1, still 0. So we're looking for the angle whose sine value is 0. And since we've already found that over here, we've kind of already done that, but let's take a look at what we're going to get. So the only angles that have a sine value of 0, again, are at 0 and at pi, so plus 2 pi n, and then plus 2 pi n. Now it appears that we'd end up with 2 more answers, but these answers are covered by this answer. So if you think about n, and n can be any integer. So if n is an integer, if n is 0, then we have 0, which is getting us this one. And then if n is a 1, that's pi halves. We don't need that one necessarily for this answer, but if we go to, if we want to get to 2 pi n, then we just take it if n gets out here to a 4. So that's what we're going to have our 2 pi for that one. So all of these are going to be covered by those. So really, all I need are these 2 answers in my final structured answer. Okay, so quite a extensive lesson here. We had several different examples on different identities. We had double angle identities, half angle identities, sum to difference, difference to or sum to product, product to difference and sum. Reducing, we had, come on, give me the name of those. power reducing. So quite an extensive lesson. Keep working on those the best that you can. Ask questions you have in class, and we'll try to take care